Let's go through WAKISSHA Senior 6 Math Paper 1, 2026, Item 1. The city planning authority is optimizing its urban transport infrastructure by mapping key service hubs using three-dimensional coordinate system. The current hubs are located at M, which is having coordinates 2, 4, 3 kilometers, N, which N is 8, 6, then 1 kilometers, and the P, which P is 4, 10, 2 kilometers. The planners have identified a site for new logistic depot at Q. Logistics will be at a point 14.8, then 4 kilometers. The project director will only approve the depot if it lies on a straight supply line defined by hubs M and N, as this ensures efficient traffic flow. So they have said that if he is to construct, the project director will only approve the depot if it lies this one here. This is the depot Q. This is the depot. If it lies on a straight line, M of M and N. So what we are going to do, because the note is going to be asked, if you are to look at part A, the task is, will the project director approve the new logistic depot location? It will only be proved if M, Q, and N are lying on a straight line. So what we do there is, we are going to test for collinearity for a straight line. So I'll say that if M, N, and Q are collinear, for them to be collinear, then Mn will be equal to a given constant. I can even say Mq. There will be a common constant. Mn will be having a common constant that relates it with Mq. So that is what we are going to look out for. And knowing that Mn is the same as On minus Om, which is equal to our constant we are looking for. Mq is the same as Oq minus Om. On was given as 8, 6, 1 minus Om was given as 2, 4, 3. This should give us a Casimir constant, and OQ was given to us, this is the depot, as 14, 8, then 4. This, let me introduce another bracket, then minus OM 243. 8 minus 2 gives a 6. 6 minus 4 gives a 2. 1 minus 3 gives a negative 2. This should equal to a constant 14 minus 2 will give 12. 8 minus 4 will give 4. 4 minus 3 will give 1. Equating the x to the x, it will give me 6 being equal to 12k, and the k, if I divide through by 12 on both sides, at this point k will just be equal to a half. I want to test and see if it is going to be the same for all. Now when I go to, this has been x equated to x, then I go to y, which is 2, will also be equal to k times 4. Then divide by 4 on both sides. K is also equal to a half, I'm seeing the constant is the same. Let us not jubilate and stop there. Let us proceed to the last one, which is a negative 2 is equal to just k, implying that k is equal to negative 2. So this signifies that since the constant is not the same throughout, then point Q does not lie on a straight line with M and N. So I'll conclude and say, my conclusion will be, therefore, since the constant K is not uniform throughout, or is not a constant for all x, y, and z, Q does not lie on the straight line, with M and N. So, because the question is, will the project director approve the new logistics report? So, the project director, conclusions are so important. The project director will not approve the new logistics depot location. Conclusions are a necessity. Then we can proceed with the same item. The second paragraph is saying, for emergency rapid response, a fire station is proposed at R. Now they are proposing a fire station. Let me first put R. The fire station is proposed to be at point R, which is 248 kilometers. The planner must depot the shortest distance. The planners must determine the shortest distance from the fire station to the plane containing MNP. So if you are to get a plane that contains, a plane is going to be like a region that contains M, N, and a P. But now there should be they want a shortest distance. The distance that is supposed to be there should be less than 10 kilometers. So let us formulate a plane given 3 coordinates. Since we have M, N, P, I'm going to start by getting my Mn, which I already have. Mn is 6 to negative 2. 6 to negative 2. Then what I'm doing is I'm getting the direction vectors. So I've got Mn, then I need to also either get NP or MP. N. So let me say NP, since initially we didn't get NP. So NP will be OP, which is 4, 10, 2, minus ON, which is 861. When I subtract off, I'll have a negative 4, then I'll have a 4, then I'll have a 1. This is NP. And in vectors, I can call this direction vector 1. I can call this direction vector 2. Then I need to get the vector that is perpendicular to this and these direction vectors, which will be the normal. I can either cross the 2, or I can say, that I'm going to cross. I will say let the normal let the normal to the plane I want to generate. Let the normal to the plane be, let me say n is equal to p, q, r. I'm saying that if I have the direction vector 1 and I dot it with the normal, I must get a 0 because the dot product of perpendicular vectors is a 0 because the angle between them is 90. Then D1 is 6 to negative 2. The normal is PQR. PQR, this is equal to 0. When I multiply, I'll have 6 times P, which is 6P, plus 2Q, then minus 2 minus 2R is equal to 0. I can make R the subject, let the R go the other side, and I divide through by 2. So R is going to be equal to a 3P plus Q. I call that equation 1. Take R the other side and divide by 2. That has been D1 times the normal. Then I'm also saying that the normal, if I get the normal and I dot it with the second direction vector, I'll get a 0. Still, I introduce the negative 4, 4, 1. I dot it with the normal, which is PQR, as we defined it. This must equal to 0. Then when I multiply, it becomes a negative 4P times the 4Q, sorry, plus a 4Q, then plus 1 times R is equal to 0. Since I have made R the subject, still I can also make R the subject and I eliminate it. So R is going to be equal to, when the negative 4P crosses, it becomes a positive 4P, then minus 4Q. This is equation 2. Since all of them are equal to R, I'll just say equation 1 is equal to equation 2, and equation 1 is 3P plus Q is equal to 4P minus 4Q. Then, collecting like terms, let the 3P go the other side, and the 4P comes this way, such that I have 5Q is equal to P. So P is equal to 5Q. Then after getting P is equal to 5Q, go to equation 2 or equation 1, N. I'll say from equation 1, wherever there is P, I'm going to put there the value of P, and it is going to be R is equal to 3, but P we are saying is equal to 5, P is equal to 5Q, then plus Q. So our R is going to be, this will be a 15Q plus Q, which is 16Q. Now you find out that I have established P in terms of Q. Let me call this star. Then I've also established R in terms of Q. So the would-be normal now is going to be given. Remember, we said it is P, and we are saying P is 5, it is in Q. So I take the 5Q, I can first take the 5Q. Then since we are in Q, I'll just take the Q. Then R is 16Q. My goal is to see that I have a Q throughout. If we are in P, this one would be a P in case, and this would be maybe 1 over 5P, like that, 1 over 16P. So in this case, we can factor out the common term, and that's the Q. So when you factor out the Q, our normal simply becomes the coefficients, which is going to be 5, 1, and 16. When you use the crossing method, you'll get the same answer. But this is not what we want. What you're interested in finding is getting the equation. So the formula of the equation of a plane is A dotted with the normal that we have been looking for is equal to the normal times r, of which A is any point. Any point, by any point I mean either M, N, or P. So I'm going to use M as my A, 2, 4, 3. So A, I'm saying it is 2, 4, 3. I'm dotting it with the number that I've got, which number is 5, 1, 16. 5, 1, 16 is equal to still the normal 5, 1, 16 times r is the coordinate x, y, z, because our plane is supposed to stay with x, y, z. When I multiply 2 times 5, I get 10, plus 4 times 1, I get 4, plus 3 times 16, that is going to be 40, that is going to be 48, is equal to 5 times x, that is 5x, plus 1 times y, plus 16 times z, 16z. When I bring everything this side, I'll have 5x plus y plus 16z being equal to, or let it cross equal signs. This is going to be 48 plus 4, that is 52, plus 10, 62. But since they want the distance, let the 62 be this way, such that I write the equation of the plane as it is supposed to be. This is becoming 5x plus y plus 16z, then minus 62 is equal to 0. I'm writing it in the form of ax plus by plus cz, then plus d is equal to 0. This is the general equation of any plane. So the question was, help the planners to check whether the fire service response distance is adequate. There is something they said. They said that from the fire station to the plane containing the hubs M, N, P, to assess the response time, the fire service response will only be confirmed adequate if this distance is less than 10 kilometers. So the distance that is we are calculating for is R, which is 248. R is 248. We want to see the distance from this point to this plane. Is it less than 10 kilometers? If so, then they can go ahead with their plan. So the distance is given by the magnitude of this equation of the plane, ax plus by plus cz plus d. The whole of this is over the square root of a squared plus b squared plus c squared, whereby this is when we are we are looking at this equation and this point. So our a is the coefficient of x. So a is the 5, b is the 1, c is the 16, just the normal. Then d is a negative 62. D is equal to negative 62. Then, because we are substituting here, x is the point we are going to from the plane to a point. X is 2, y is 4, then z is equal to 8. Then we are going to see, after computing what we have, substitute the distance is going to be given by a, which is 5, times x, which is 2, plus b, 1 times y, 4, but we have a magnitude, plus c, which is 16, times z, which is 8. Then now this is a minus, so this is going to be taken as a minus 62. So all of this is over the root of a squared, which is 5 squared plus 1 squared, and plus 16 squared. On computing, we are having 5 times 2 plus 1 times 4, and plus 16 times 8. minus 62, 80. So in the numerator, I have 80. It's already a positive. We take it as it is. Then denominator, I have 5 squared plus 1 squared plus 16 squared, which is 282, and the root. This is the root of 282. Of course, these are kilometers. Then when I say 80, divide by the answer, the distance is going to be 4.7639 kilometers. The question was saying part B, but this is part B starting from here. The question was saying, help the planners to check whether the fire service response distance is adequate. They said it should be adequate if the distance is less than 10 kilometers. So I will conclude and say, since the distance is less than 10 kilometers, the response, fire response is going to be, it's adequate. You're supposed to conclude. Then we proceed still in the same spirit. They have told us that during the city expansion, this is the same item, by the way. In this item, we said we are looking at 3 topics. We are looking at, let me break down these topics. We are looking at trigonometry. We are looking at trigonometry. We are looking at geometry. In geometry, we look at geometry 1 and geometry 2. Then finally, we also look at vectors. So the first approach, I used geometry, but you can also use vector approach to check and see if the points are linear. So we are now continuing that. During the city's expansion, INGNI has mapped 3 sensor nodes along the perimeter of a circular restricted access zone surrounding a downtown square. The 3 nodes were recorded at X. So we have a circular node. I can indicate it there for part C. Then one of them is located at X, and X is 16, 4. Then we have another one, I can say it is at Y, and Y is at 4, 16. Then the other one is at Z, and the coordinate at Z is, okay. So we are having 3 nodes, and these nodes are in a circular restricted zone surrounding a downtown square. The 3 nodes were recorded, and these are their coordinates in kilometers. The city authority must determine whether a newly planned emergency access road passing through point S, so they are making a road which passes through S, having coordinates 415 kilometers. They want to see if this road lies within the restricted zone for security clearance. These nodes are located along a circle, but I'm assuming there might even be cameras observing to see. This is the area they are clearing off. For security purposes, we are focused, and we are seeing it in that way. Then the question is saying, does the emergency access road lie within the restricted security zone? This one here. Will it lie within here? We are going to test that. How? We shall first of all get the equation of the circle. Then when we get the equation of the circle, we shall get the distance, which is the radius. I'll get the radius, which is, I can say it is the distance from here to Y is to the circumference, either to X or to Z. Now, the test is going to be, I need to get the distance from here to here, which is the radius. And I will also need to get the distance from the access road, which is at a point S, to also the center. If the distance from the center to the circumference is less than the distance from the center to this rod, it means that this rod is outside of the clearance zone. But if the distance from the center to this access rod is maybe somewhere here, and it is less than the radius, it implies that the point S is within the restricted area. So what I'm going to do is getting the radius and getting the distance. But I can't get the radius of this except if I get the center. And when I get the center, it can become very easy for me. I can just say, let me call this point A, and I call that point B. Now I'm going to get the equation of Z and C. I get the equation of Y and C. I get the equation of X and C. They are supposed to be equal. So I'm saying CZ is going to be the square root of, let me say A minus 4. But all of this is squared. The formula distance between 2 points, x1 minus x2, the whole of it in brackets, then plus y1 minus y2 squared. This is what I have. Then I also need to get cy. Still, I'm going to use the same. I say a minus 4 squared, then plus b minus 16 squared. But for purposes of solving them, I need to say that the CZ, I also need to, let me get CX, that I can say CZ is equal to, since this is radius and this is radius, I can say CZ is equal to CY. I first equate the square root of, as I expand it, I come up with a squared plus 8a plus 16. This is for only here. Then I add on the expansion of this b squared minus 8b plus 16. We are saying this is equal to cy, which is also the square root of, expanding this will give us a squared minus twice the product of that, which is 8a, then plus 16. Then I also expand this plus b squared minus twice the product of this and this, which would be 32b, then plus 16 squared is 256. At this point, I'm dealing with thirds. I square both sides to eliminate the square root. That becomes quite easy. Then when I eliminate the square root, I can try to combine some values. A squared plus b squared, then plus, I have 8a minus, let me first put a minus 8b. Then I'm having 16 plus 16, the positive 32 is equal to, still I have a squared. I start with b squared, then I have a negative 8a minus 32b, then 16 plus 256 will give me 272. Then the a squared will cancel if they cross. Then I have this 8a. I'm adding on, when this 8a crosses, it's going to become 16a. Then plus, I have a negative 32b. When it crosses, it becomes 32 minus 8, which is 24b. Then when the 32 goes the other side, I'll have a 272 minus 32, and this is 240. I think I can divide through by 4. If I divide through by 4, let me see, by 4, I'll have 4a. Is it by 4? But I think by 8. By 8, I'll have 8a plus 3b being equal to, if I divide it by 8, this is 2. 2a plus 3b is equal to 30. This is equation 1. I said CZ is equal to CY, and I'm also going to get CX. I equate it to n of these two. So still about CX is going to be the square root of A minus 16. I need to get the second simultaneous equation that I will solve with this. Then plus B minus 4. All of it is squared. Then I expand and try to simplify Cx also, C to x. I get the square root of a squared minus 32a n plus 256 plus, this is b squared minus 8b plus 16. So I'm going to also say Cx is equal to n, whether Cz or Cy. I'll say Cx is equal to Cy, and now the Cx is a squared minus 32a plus 256 n plus 256. When we add on a 16, we saw it was a 372. Let me just substitute for plus 272, then plus b squared minus 8b. This is Cx is equal to Cy. We got Cy as this one here. Cy is a squared plus b squared minus 8a plus 32. It's a minus 32b, then plus 272. 272 is going to cancel out. A squared leaves, b squared also leaves. Then I'm having a negative 32a plus 8. When the 8 crosses this way, I'll have 32 minus 8, which is a negative 24a. I'm saying a negative 32a plus 8a. Then when I take 8b the other side, I'll have negative 32b plus 8b, which is going to be a negative 24b. Dividing through by negative 24 by negative 24, this implies that A is equal to B. And if A is equal to B, I'll put this as my second equation. Then I go to the other equation and I substitute. Wherever there is B, I put there A. So it becomes 2A plus, because it is 2A plus 3B is equal to 30. Wherever there is B, I'm going to put A. So 2A plus 3A is equal to 30. This is 5A is equal to 30. Dividing through by 5, I have 6. And since A is 6, B is also 6. B is equal to 6. So my center is at the point 66. I'm not yet through. So I have established 6, 6. Now I need to go ahead and find the radius. How do I get the radius? I said that I just substitute Cy is our radius. cy is the radius. So let me substitute and see what the radius is. I'm saying cy is equal to cx is equal to cz, which is equal to the radius, but this is going to be equal to the square root of, I just get and substitute. We have got our a as 6. So 6 minus 4, the whole of this is squared, then plus b minus 16. b is also 6 minus 16 squared. This is going to be the root of, this is 2 squared plus, okay, this is going to be negative 10, but when I square it will become a positive. So I'm having a 4 plus 10 squared, and the answer will approximate to 10.198 kilometers. So that is the radius. Now we are remaining with the testing to see if the distance from here up to point S, if it is less than this, it means that this access road is in the restricted region. If it is greater than this, it means that it is outside, because that is what we are attempting. Now let me use this same space. I need to get SC, distance SC, which is going to be, our S was given as 4, 15. So it is going to be 4 minus 6 squared, then plus 15, still minus 6 squared. 15 minus 6 squared. When I compute, I have 2 squared plus 9 squared. 15 minus 6 will give us 9 squared, but it is under a square root. So this is going to be root of 85. Root of 85, which is approximately 9.2195 kilometers. That is the distance SC. Now, my conclusion, if I go back to the question, it is saying, does the emergency access road lie within the restricted security zone? My answer is yes. Why? Because its distance to the center that defines the circle where the nodes were placed is less compared to the radius. So it is within. That is method 1. The second method, you can get the equation of the circle and still you get the center and the radius from it and you proceed. But this is also okay. Now we proceed still the same item. They say finally, during system testing, engineers discovered that the signal reach of a mobile weather station is defined by, this is how they defined it. They said the signal is defined by S is equal to 24 sine 2 theta plus 7 cos 2 theta. There is a minus 3, then we close the brackets. These are kilometers. Then the Weather Bureau has a target that maximum signal reach for their stations of at least 20 kilometers to guarantee coverage for all peripheral districts. They have said at least, so it should be greater or equal to 20 kilometers. The signal is that. Now they have talked of the target that the maximum signal. So we need to get the maximum of this. But since we are having trig functions, we can express this in the R formula that we covered in the previous lessons. I'm having a sine and a cos. I start by letting this, I equate it to R into, since I'm having a sine first and a cos, this must have come from, this is 2 theta plus alpha, R this. Then the next step is to expand the right-hand side, 7 cos 2 theta. Expanding, I'll have R from compound angles, that is sine 2 theta cos alpha still plus r into cos 2 theta sine alpha. If you don't know where these are coming from, you just watch the previous trig videos. Then by comparison, compare those that are in sine 2 theta this side. I have a 24. This is equal to, by comparison, the one that is this side, that is having a sine 2 theta, is r cos alpha. R cos alpha. Oh, that's equation 1. Still comparison, that those that are having cos theta, the coefficient here is 7. Then here the coefficient that has cos 2 theta, sorry, it is cos 2 theta. The coefficient is r sine alpha. R sine alpha. This is equation 2. Then if I'm interested, because I need to get that alpha, I'm interested in getting alpha, I'll say equation 2 divided by equation 1, and this is going to be r sine alpha over r cos alpha is equal to 7 over 24. Why don't you say equation 1 divided by equation 2? Yes, we shall have a quote, but getting a quote up on ordinary calculators might seem to be hard. So I will say tan alpha is equal to 7 over 24, and alpha will be the arctan of 7 over 24, which from our calculators, which are supposed to be in radians, will give us 16.26 degrees. Then I also need to get the value of r. When I look at from equation 2 or any equation, r is going to be equal to 7 over sine alpha, 7 over sine, but alpha is this answer, which is not rounded off. Please don't round off that answer. In your calculator, just say sign of the answer, then you say 7 divided by your answer. R will simply be 25. It's a whole number. Now, this implies that this one here, which is here, we are going to write it as a 25 sine, and I'm saying our new s is going to be, wherever we are seeing this, we are putting a condensed value, which is 25 sine 2 theta plus alpha. That is the whole of this. It is this. But our alpha, we have it as tan up, which is a 16.26, which might not work for us in this question. Then minus 3. Since this is the equation of finding the signal in kilometers, they want the maximum signal. So I need to get the maximum. I maximize the 25, which is a constant. I stay with the 25. Then I maximize the sine, maximum of sine theta and cos theta is 1. If you have to look at their curves, the maximum you can find them at will be maximum 1, then minimum will be at -1. That's how they are. If you want to see what we mean, go to your calculator and press the sine arc of anything greater than 1. You can even use a 1.1. It will give you math error because the maximum is 1. So the maximum of a sine, the whole of this is a sine with its angle, is a 1, then minus 3. Now I maximize this because of multiplication. I maximize this. Now because of subtraction, I minimize, but this is a constant, so minimizing a 3 gives me a 3. So I'll have 25 times 1, which is 25 minus 3, which is 22 kilometers. But the condition was, if it is greater or equal to 20 kilometers, then there will be a sufficient coverage, the coverage for all peripheral districts. So the question of part D is saying, will the engineers achieve the required signal reach for the weather station? My answer is yes, they will achieve it, because the maximum signal distance is greater than the 20 kilometers they want. Thanks for watching. We meet as we do item 2.